tagadan 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 pam pam tagadan 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 pam pam tagadan 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 pam pam tagadan tagadan pam pam tagadan 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 tagadan pam pam.
Thank you. Our next presentation comes from Alexander Rubensaal from ABC Systems.
Hello everyone. So the open storage design is just one page on paper, but let's have a look. I welcome you to ABC's kitchen, and before lunch it's just the right time to show you or to let you taste some of our few appetizers of ABC. So the year is slightly exaggerated because we only started in '86 with storage. Storage having external SCSI subsystems under Novell. This was really the start. Then, being an old comer, you see what has changed, may be interesting in those years. You see in 14, we had this interesting PCI NVMe, already starting using it in 2012, and they have been running for 7 or 8 years until we had no longer drivers under Linux, but they never failed. But there was also some pitfalls when you have set so much hope or believing in the ruler that has never appeared. That's the past, but what has changed? Let's have a look. Now there's certain challenges. Disk drive capacity increases permanently. So on the roadmap, we may even see this year or next year 30 terabyte and 50 terabyte. However, what about performance? So there is from Seagate and Western Digital, we have dual actor inter disk drives available, which means double performance. However, with those dual actuators, you have to sacrifice one SAS port. And you also need double of power. So it's restricted where you can use it. So one has always questioned what's behind. So what we see, the change is also here. So the main figure is now not just looking at the gigabyte per second of the RAID controller, of single box, and adding capacity, while we have to take it into relation to the entire petabyte. So we want to see over all our petabytes, we would like to have 10 gig over all petabytes and not for a small portion of it. SSD is still an extremely emerging technology, so to build really good SSD is more complex than a RAID controller. And you know how many good controllers are really available in the market, so it's not a common, or it's not an easy job. Then we see we have the different ratios of throughput, and coming up PCI 4 and 5 with those lanes providing quite a lot of bandwidth. And for NVMe, we must see the server rules the PCI bus. So the server is probably home of NVMe. Okay, we can cook in a network centrally with 1000 degree. However, when it ends up or arrives the client, it may only be 10 degree or 100 degree. So one has to care about, and we only used this design in the server, and you see why. And the main point is also to question what's around and not just to go with a single proposal of the manufacturer, but to question, is it really a good technology and a good thing? Now, let's have a quick look at the architectures. You know, the old picture left, when we had rate controllers inside, then connecting JBoards and JBoards just to create capacity. What have been funny when we have been thinking or had in head terabytes and not petabytes. Then came up the entire story with the software rate. And here, then we use, for instance, Spectrum Scale, ZFS, or other products in a twin-tail architecture in order to get redundancy with the JBoards. Then the next step has been, because we should also scale with performance and not only with capacity, then using dual rate controllers here, and maybe still having JBoards, or if it really comes to scalable throughput, then remove those here, because normally we have now more than enough capacity in such boxes. Now, how to proceed? Let's be a little bit innovative, and what means innovative nowadays? Go back, and you may remember, some of you, when Jesus was tested by the Pharisees, he gave this answer, okay, so give Caesar's what Caesar's, and to God what's God's. And we translated, so give hardware what is hardware's, and to software what's software. We have realized last year the expansion of the largest CERN external storage. It was an expansion of 84 petabyte, arriving now at 100 petabyte, using those 4,600 drives, HDD. And it's interesting when you see how many nodes we needed. We just have done it with 11 redundant nodes. We only used around 500 cores. Then we only used 6 racks around. And then if you go to software-defined solutions, we will propagate, okay, have a 3-way mirror. And if you follow the rules to have a single core per disk, then it becomes an unbelievable design. Okay, you can improve it by going with erasure coding in this or this way. And you know, it's not necessary to calculate power and cooling, because it's just prohibitive. You should not follow this way unless you have a power station just behind your data center. So this has turned out after we have done this in Germany, and also being always faced with the manufacturers, what can you do, what should you do, and evaluating what's going on. But now let's check some hardware, and there's some true innovations. Seagate has introduced some years ago to have log files over the past 1,000 hours of operation. This has been a requirement of the exascalers, and up to now, no one else used it. But Seagate now decided to profit by those logs, because those logs are dynamic. They show a development, and not just rely on the status you get from the smart information. So the system is self-healing, which means one has seen if a disk fails, then it's maybe just 1 or 2 read-write heads. So what does ADR, the autonomous drive regeneration, do? They reformat the drive within 1 or 2 hours and take it back into the array, which is possible when we go with erasure coding because we don't need to have identical disk drives. So in addition, we have the possibility really to run erasure coding on such boxes. And we have 5 nines, and it's a really extremely interesting building block we like to use. Okay, it's complemented with heads and other stuff, but this is a basic component. And the interesting thing is also, because you see, the rebuild time, which becomes more and more a problem with the huge drives, you can it reduce by 90%. And now you see, not talking about pricing or to give a price indication, I think it's not very interesting because just the price-performance relation gives you an idea what can be done. So this is indicative prices from recent offers. So currently you can take euro, Swiss franc, and dollar more or less 1-to-1 because it's just indicative. You see, we have 106 drive with 18 or 20 terabyte drive. We have a dual controller. We have this adapt erasure coding. We have autonomous drive regeneration. So we have a very good bunch. And now one has to ask, why should you leave erasure coding calculations to software when you have finally powerful hardware controllers? Because erasure coding is more close to hardware than to software. And having disk hospitals on the file system, okay, you can have it. But now when we see such building blocks, one should take profit of it. So then here are some examples what you can do. You can do a shared storage. You can have 4 storages because we have 8 host ports on this storage box. We can have a 2-head in high availability configuration with multi-protocol support, or we can do scale-out clusters. So there's a lot of possibilities just creating building blocks. So the point is just to find here the server with enough PCI slots. So we use Supermicro servers most time, coming with 7 PCI 4 slots and having, I say it's a naked motherboard because you don't have rubbish you don't need on the motherboard, and it's I/O oriented, and that's a very good deal. And when we go to the SaaS industry, so I always tell them, listen, are we still in the sleeping car? Because what's going on with SaaS? So, but we don't need SaaS 4 interface at the moment on the disk side, because just with 30 or even less hard disks, you can saturate the 4-lane connector of SaaS. And if we follow this way, we have to have a parallelism and to segment, for instance, a JBOD or a disk subsystem, at least a 90 drive box, at least into 3 autonomous areas. If you don't do that, it's useless. So, because you can't take out the potential that's available. And now we are waiting for SaaS 4, but SaaS 4 is mainly needed for the infrastructure. So to have HBAs, RAID controllers with SaaS 4, which are now slowly appearing, but the main thing would be to have the infrastructure, to have the enclosures with SaaS 4, and to bring really out what's available. Because there's still a discrepancy between disk size and what's available to bring the potential out. And what we see also that sometimes we feel customers are too patient with the manufacturers. One should be harder and ask for really the new technology, because as long as there's no demand, they don't see a necessity to move forward. Now let's have a look on the performance here. And please keep in mind, we are looking at I/O and not at calculation, which is a different view. When you have to do a lot of calculations, you may go with two-socket design. But in I/O, you see this has only disadvantages, because this is a picture of the old sidecar race. So the driver is here, and the second has to rely on the driver. And for instance, you see where you would like to boot, you have to go over the bridge of troubled water to get your access here to boot devices. But the worst case scenario is when you are having NVMe, because then you can say, okay, probably you have the NVMe or the data 50% always on the wrong CPU. And since this will quickly become a bottleneck, respectively, you can't take out the potential of the NVMe. And therefore, we created this speedway storage server approach, which means prefer to go with single CPU servers, as well as take CPUs with utmost PCI lanes. And you know which CPUs this is, and that's what you are using. And now you see here what's coming with the PCI 4 and PCI 5. So at the moment we see the PCI 5 NVMe won't go far beyond 6 to 8 gigabytes per second read and write. And if I have, already on the X4, I could have, at least 2 NVMe now in PCI 5, which will be fantastic, because then suddenly we end up having 256 possibilities to have drives directly connected without stopping them at red lights, crosses, and so on, and not going over a bridge. And you see, it's obvious. You are so much faster than those guys here, and this you can just translate how to do a good or a better storage design. And here is a typical picture, what we always see when inquiries are coming in. They say, I would like to have an HBA, a 3-mode HBA, or a 3-mode RAID controller, and then connect, for instance, 3 NVMe. And then you see, we really create latency, because the vertical traffic directly to the CPU is interrupted with this HBA horizontal traffic. So we don't like such design, and we always look to turn around. And it's possible to do it, and we mainly use systems of Supermicro, and everyone thinks they are crazy having hundreds of servers. But if you have, if you're interested to go through all those 50 or 100 drawers and find the correct system, so you are very happy, because then you can off the shelf provide a really customized solution without any price penalty. And unless you follow such a design like here, you can't take profit of the full speed what's available. And many customers are available, because NVMe and SSD, they're always faster than HD. That's clear. You say, what an improvement. but maybe they see only a fraction of the possible improvement. So then here is some examples how to design such clusters. And just following the last point, sometimes it's also a hard time for the customers because our concept is to show them variants, other possibilities. And when we have an inquiry or we make a proposal, we elaborate several solutions and discuss them with the customer in order to find out what they really need. And this is most time looking back over those more than 30 years. I have to admit it's sometimes really hard because often customers just want to have a single solution and to go with it and not to evaluate. And then I say, okay, but you can say, God or nature gave human a brain. Now you can use it in two ways, not at all or at no cost. And this is an important point. This comes out of the experience that making proposals, and you see these are minor differences. These are 6-node clusters, and you can start quite modest, but you can expand. Then it depends, okay, would I like to have more NVMe and so on, then we can add, in this case, we can add clusters, we can add NVMe in such systems. And so it's important, since I mentioned in the beginning, NVMe is emerging technology, or flash is still an emerging technology, and now one has seen when you use the NVMe, in the beginning you get a very good performance, but after a certain time it goes down. And now there's products available that have seen this effect and they have improved the algorithm, so you have a constant and consistent performance of the NVMe. Okay, this NVMe is maybe 10% higher, but it pays off. So another example maybe is this. We always need redundancy. So we take again 2 servers, and now we are going to use Senior software rate within, and then we mirror those 2 systems, for instance with spectrum scale, so we can take down 1 server for maintenance reason and have complete redundancy. So that's another approach, depending on the capacity you need, also on the performance. Then there's an interesting question, what's next? Huh? What we see is composable PCI architecture. So we will see external PCI switches, 5 and mainly Zen 6, and having a bunch of GPUs, a bunch of RAM with CXL concept, and a bunch of flash. And one of our manufacturers, he has a prototype made now in PCI 4. It's ready to go, but it doesn't make sense because it still relies on a PCI add-in card, and this is last generation of Samsung. Afterwards there won't be, so we have to go with PCI 5. And they have seen latency, if you go over the switch, is similar to what you see between 2 CPUs in a dual socket concept. And what we are looking here is mainly also for the JBOF, and to build a PCI JBOF similar to a SAS JBOF, but having the connection not only with SAS, but with PCI. And this is already running with PCI 4, but doesn't make sense to sell it because, yes, Samsung will cancel, respectively all NVMe manufacturers will cancel the PCIe add-on in cards with NVMe. So it's only the format like U3, But this is already running, and such things have been already in such concept in Al Capitan. And this is a very interesting concept, and you see, this gives you a totally new idea what can be done. Please.
How many links do you have from the G1 to the switch?
So the switch will around have 144 ports, and here it's up to you how many you will take out.
So you can do that all the fail over.
Yes.
Okay.
Yes. It's quite challenging to do this on the PCIe, but I think it's because you have the natural bandwidth you have available without many translations, and it's up to design whether you make overscription or not, depending on the number of connections you may have here.
Is there any limit from the cabling part?
No, we have already PCI 4 fiber optic cable, a little bit the high price, but we have the same also done in this project with the 100 expansion of this 100 petabyte cluster, because the boxes have been spread over several racks, so we needed longer SAS cable coppers. And this is not a good fit, and so we are currently testing or validating the fiber optic cable. The problem in such areas is, you know, this is not a mass product, it's a project product. Then you have to be happy finding a manufacturer who does the job for you with the quality. And we tried for this 80 petabyte expansion, we tried, and then we went to look at Molex, at Amphenol, and Amphenol had 9 cables on stock. We bought some more, but we needed around 500 cables, so we couldn't do it. It was just for testing and to get experience and to see how it's running and working. And so the manufacturer where we have set up is a Japanese company, and they do all kind of cables, so even cables that are thinner than hair, because you go into the body, make a photo of the heart internal, and they do such cables, so they are quite competent, and then we can rely, okay, that they do proper stuff, and we let them also, for instance, Seagate, from whomever this storage box is coming, we let them validate, and but that's interesting. And when one has always to look for the next hole to go through and to find a solution. But this has always been, our intention. We have always been looking to find the solution in open architecture and get the components we need in a standard flavor. Yes.
Okay, and that's where you can have multiple devices.
Yes.
Okay, that will be active passive.
Yes. Yes. And here it's interesting because here you could have a shared memory between those machines. So that's extremely important. So when I summarize what we are doing, what's the difference? We completely go in the direction of open architecture. And I can give you an example out of other class projects where we've done roughly more than 40 petabytes. What's the difference? Because we are normally faced that the customer says, but listen, I have from manufacturer 1, A, B, C, and so on, I have single support, and I can rely. And then we say, okay, but you have to, because why? Let's take the example. We have the HPA. We take the standard Broadcom LSI. You can buy at every corner. While the manufacturers we have seen, they take the same chipset, maybe even the same adapter, but then you see suddenly a manual with 40 flavors of HBAs, all with the same LSI chip. And then you say, but why is the difference? We say, okay, yes, this is optimized for system 1, this is optimized for system 2, and then comes the problem, system 2 runs out of the life cycle, and this has now caused tremendous problems. So our approach is going a conceptual way, not to go just the boring way manufacturers prefer and just pass through what's on the truck, pass it through to the customer. So we question what it is and say, okay, this is too old stuff and this is not adequate, and then we jump to the next manufacturer, which means in the view of the manufacturer, we are often not seen as a so-called loyal partner because it takes the freedom to take better components in an open architecture. So most, I remember IBM Switzerland, they always recommend the customer, also told the customer, ABC is the best storage partner we have. But they would never have recommended it to the customer because there was a big fear that maybe a certain component would not take of IBM, but of, let's say, the original from Broadcom or what so on, or having, let's say, all the Mellanox in the standard version without adaptation to hardware. Okay, you may have slightly advantages going with an OEM version, but you have to take into account the life cycle and how long is the manufacturer interested to support the product. And suddenly he says, okay, this is gone, and okay, you could use it for 5 years. We have recently experienced you could use it for 5 years. But if you would like to expand a 10 petabyte cluster with the current system, and you say, okay, it's not possible, then it's, in our opinion, it's a no-go. And now we have hard discussions between customer and the manufacturer. But our concept is always open architecture. The main thing is quite trivial support around the next corner. And our intention is always, because that's what we have learned from the big manufacturers, to be able to remove ABC out of the project without any headaches to the customer, and not making a total vendor lock-in. And I think this is, in the long run, always a better concept, because earlier or later the customer will realize how flexible he is or he is not flexible. So this is this short overview of open storage architecture. And if you have any questions, please, I'm here to ask, to answer your questions.
Pam pam,